Good day to our thesis advisor and chairwoman, Engineer Helen Grace Garcia, and to the panelists, and also to the Dean of College of Technology, Dr. Alito Jean San Diego. I am Remy Ciboleros and would like to greet you all a pleasant day. We will be presenting our proposed study entitled Reverse Vending Machine for Polyethylene Terephthalate Plastic Bottles, together with my co-researchers, Ms. Mabel Fernandez, Mr. Arvi Oraliza, Mr. Zimran Salvado, and Ms. Kathleen May on site. So without further ado, let's proceed with the introduction. With the increasing amount of waste generated and limited landfill space for waste disposal, recycling is undoubtedly one of the important means to manage waste effectively. Millions of waste and useless materials are being compacted as garbage, having no proper waste disposal in the world every day. Even in most developed and industrial countries, only a small percentage is being subjected to the 3R mantra: reuse, reduce, and recycle. While the country has an 85 to 90% waste collection average rate in urban areas, it plummets to less than 80% in rural areas. The autonomous region in Muslim Mindanao has collection rate of only 40%. Another contributor to the growing post-consumption plastic waste problem is the lack of a proper waste management infrastructure. The study highlighted key areas where plastics are leaked into the oceans, and this includes rural areas that do not have a proper waste collection method due to its low waste density, and high-density urban areas that are not able to cope with the influx of development.
Statement of the problem. What design parameters should we consider to develop the development of a reverse vending machine for PET plastic bottles? What development and implementation strategy should we adopt to be utilized to ensure that the development of a reverse vending machine for PET plastic bottles? What evaluation parameters should we access in order to measure the performance and acceptability of the development of a reverse vending machine for PET plastic bottles? Objectives of the study. To fulfill the main objectives, the following specific objectives should be met. To design a reverse vending machine that will be able to recognize if the material inserted is PET plastic or not. To develop a machine that will vend off equivalent amount after a successful transaction. To evaluate the reverse vending machine for PET plastic bottles in terms of the following: A. Functionality, B. Accuracy, C. Cost effectiveness. Significance of the study. The study aimed to test whether the development of the RVM for PET plastic bottles alleviate problems in waste disposal and thus promote recycling among the students of University of Science and Technology of Southern Philippines. We researchers also believe that this study would be beneficial to the environment and future researcher. Conceptual framework. This is our process flow, which has an input, determine all the possible materials and equipment to use, collect all materials and equipments, gathering all data of materials and equipments, a process, a design a RVM, applying a various procedures as guidelines, develop a prototype for the RVM, evaluate the RVM, and output, which is a reverse vending machine for PET plastic bottles. Scope and limitation of the study. The machine will be confined to accepting PET plastic bottles only with the transparency of 88.8% up to 100%, in weight 8.9 grams up to 24.5 grams. The machine has a bin that can hold plastic bottles. The machine will be able to vend off money appropriate to the number of plastic bottles inserted in the machine. The machine will be able to determine when it reaches the maximum number of plastic bottles inserted.
Review of related literature. First is the local studies, microcontroller-based solar-powered reverse vending machine. This project consists of a PIC16F84A microcontroller, 2 proximity range sensor, and the solar power system. The microcontroller is programmed by activated by the 2 sensors simultaneously.
Next, we have the development of reverse vending machine using recycled materials and Arduino microcontroller. In the University of Saints, Malaysia, they developed a vending machine. The function of it is to separate different materials found in waste streams and minimizing the amount of goods sent to landfills.
Chapter 3 is all about the research methodology. The main purpose of this study is to develop, fabricate, and test a machine that accepts plastic bottles, specifically those made of polyethylene terephthalate, and rewards the user after a successful transaction. So this is a reverse vending machine perspective design. It has a indicator LED, insert bottle slot, coin dispenser, reward button, and donate button. So this is the flow chart of our reverse vending machine. It is start, then insert bottle. The loads weights the bottle. The machine weighs the bottle within the range of 8.9 gram to 24.5 gram. If the bottle does not meet the weight standard of the machine will automatically stop and then return the item. And if it meets the standard weight, the laser sensor determines the light intensity from the laser diode. And if the bottle is not transparent, the machine will stop and return the item. And if yes, the bottle will be dropped into the bin and counted. And after that, the system will calculate the reward and display it on the screen, and ask the user whether to receive or donate reward. If the user presses the yes, the machine will vend off equivalent reward, and if no, the thank you message will be displayed on the screen. That's all. Thank you.